Hello everybody. Today we're going to discuss this question from the book Challenging Problems in Geometry by Alfred Posamentier and Charles Sarkind. Okay? I've restructured the question a little bit, but the given conditions and what we're supposed to show are still the same. So this is basically the same question in the book, even though I have rephrased it. Okay? All right. Now, before trying to solve this problem, let's make certain observations. Okay, we have a right angle triangle OAB. Okay, we have a right angle triangle OAB. We have a right angle triangle OAB. Like this. Now, if we drop a perpendicular from O to the hypotenuse AB, the perpendicular may meet the hypotenuse like this, or it may meet the hypotenuse like this, or it may meet the hypotenuse like this. Okay, all right. Now we're going to show that this case is not possible, this case is not possible. Okay, all right. Now let's say this angle is alpha. This angle is alpha. Then, since this is 90 degrees, alpha plus 90 means this angle 90 degrees plus alpha. Okay, this angle is 90 degrees plus alpha. But 90 degrees plus alpha means greater than 90 degrees. And is this possible? Can this angle be greater than 90 degrees? No, because this triangle is right angled, and here is the right angle. So these two angles must be less than 90 degrees. So this case is not possible. Okay. Similarly, if we call this angle beta, then 90 degrees plus beta means this angle. Again, this shows that this angle is greater than 90 degrees, which is not possible because OAB is a right angle triangle, and since the right angle is at O, the angles at A and B must be less than 90 degrees. So this case is also not possible. So we are left with only this case. Okay? All right. This was the first observation which we were supposed to make. All right, let's look at the second observation that we're supposed to make. We are supposed to make it. Okay. Let's see. Since the coordinates of A are c plus chi comma 0, this length is c plus chi, isn't it? Yes. And similarly, this length is c plus psi. This length is c plus psi. Now, if we drop a perpendicular, let's see. Here we have it. PQ. PQ. Psi, C, chi, This is C plus chi, this is C plus psi, right? Now, if we drop a perpendicular, can it be something like this? Does it pass through Q? Let's see. Okay. Does it pass through Q? Does it pass through Q? If possible, let the perpendicular from O on the side AB pass through Q. Then this angle will be 90 degrees, but this length right here, this length right here is C plus chi, and so this length is equal to this length, as a result of which this angle must be equal to this angle. So we obtain a triangle in which two angles are 90 degrees. So this is really absurd. So we conclude that the perpendicular from O to the point to the side AB cannot pass through the point Q. Similarly, if we suppose that it passes through P, then this is C plus psi, this is C plus psi, so these two sides are equal, and as a result of which these two angles are equal, this angle and this angle, they are equal, but this angle is 90 degrees because OP is perpendicular to AB, as a result of which this angle is also 90 degrees. So we again have a triangle with what do you call, with two angles being 90 degrees, which is absurd. So we conclude that the perpendicular from the point O on the hypotenuse AB does not pass through P. Okay, this is the second observation. Now let's look at the third observation that we should make. B, A, Q, and P. Can a perpendicular from O on AB, can the perpendicular from O on AB be pass through a point between B and Q? Pass through a point between B and Q? Let's see. What is this? This is psi, this length is C, this is chi. Now if we join this, to O, then since this is 90, this is alpha, let's call this, I think I've used alpha before, okay, let's call this theta, then this angle will be 90 degrees plus theta. But as before, this length is C plus chi, so this is equal to this, as a result of which this will be 90 degrees plus theta, and since 90 degrees plus theta is greater than 90 degrees, we have a triangle. We have a triangle OAQ with two angles being greater than 90 degrees, which is impossible. So the perpendicular from the point O on the hypotenuse AB cannot pass through a point between B and Q. Similarly, if we assume that passes through a point between A and P, then let's join this. Oh my god. Let's join this. Then let's call this angle delta. And then this angle will be 90 degrees plus delta. So will this angle be 90 degrees plus delta? Because this length is C plus psi and this length is C plus psi. Okay? But again, 90 degrees plus delta is an angle greater than 90 degrees. So we have a triangle OBP in which two angles are greater than 90 degrees, which is a contradiction, as a result of which we conclude that the perpendicular OO dash cannot pass through a point between A and P, or should I say the point O dash is not between A and P. So we cannot have OP or OQ. We cannot have OP perpendicular to AB. We cannot have OQ perpendicular to AB. And so also it cannot be, the point O dash cannot be between B and Q and A and P. So we're left with one possible case, which is that the perpendicular OO dash from O on AB must pass through a point, between P and Q, like this. Let's call this O dash. Okay. All right. Now, let's join O and P. Yeah. Let's join O and P. Then let's say this angle is T. Okay. Let's say this angle is T. Then since this is 90 degrees, this angle will be 90 degrees minus T. Okay. Now let us assume, now since C plus psi is equal to C plus psi, if this is 90 degrees minus T, then this will also be equal to 90 degrees minus T. Okay, 90 degrees minus T. Now let's say this angle is capital T. This angle is capital T. Then let's look at this triangle. O dash. Here's O. Okay. And here's P. And we have, oh God. And we have O dash, something like this. This angle is T. This angle is T. This angle is 90 degrees minus T. And since this angle is 90 degrees, the sum of T and 90 degrees minus T will be equal to 90 degrees. This 90 will cancel this 90. As a result, we get T is equal to T. So this is equal to T. So these two angles are equal. Now let's focus on this part of the diagram. Okay. We have O dash. We have this point P here and something like this, P dash. This is P dash. This is perpendicular. This is also perpendicular. And what we have is line OP, and also that this angle is T and this angle is T. Okay, all right. Then let's see. Two angles, and since this is a common side in triangles O dash P and P dash, we have two angles equal and a side equal. So these two triangles are congruent, and as a result, if this is B, then this is B. So we have O dash P. Okay, let me clear this diagram a little bit. So what we have is that this length O dash P is equal to PP dash, which is B. Okay, all right. Now let's join O and Q. Let's join O and Q. Okay. What should I call the angle? Over there I already used T, alpha, beta, theta, and delta. Phi is used. Okay. Let's say that this angle is xi. This angle is xi. Then since this is 90 degrees, this angle will be 90 degrees minus psi. Okay. And since C plus kappa is equal to C plus kappa, sorry, what is it called? Chi, okay? This side is equal to this side, I mean OA is equal to AQ. So, since this angle is 90 minus xi, this angle is also 90 degrees minus psi. Alright. Yeah. Now, let me say that this angle is G. Okay, this angle is G. Then we have this triangle Q, O dash, and O, and here we have alright, OQ. This angle I've supposed it to be G, and this angle was found to be 90 degrees minus xi. So since this angle is 90 degrees, the sum of G and 90 degrees minus xi is equal to 90 degrees. So this 90 cancels this 90, and G is equal to xi. Okay, G is equal to xi. G is equal to xi. Now, G is equal to xi. Okay, now let's look at this part of the diagram, Q dash. Okay, here's O, here's O dash, here's O dash, and here's O dash. This is 90, and this is 90, and this is joined. Furthermore, we have this angle to be xi, and this angle was G, which was found to be equal to xi, so this angle is also xi. Okay, now just as in the previous case, we have pair of triangles with a common side, two equal angles. So these two triangles QQ dash O and OO dash Q are congruent, as a result of which QQ dash is equal to A will give us QO dash is equal to A. Okay, so this length QO dash, we found this to be A. We're basically done here. QP, okay, here's O dash is somewhere over here. This length is A, this length is B, and the whole length PQ is C. Hence, by whole part axiom, C is equal to A plus B, which we were supposed to show. Okay, all right, that completes our solution. Now, if you check this book out, this is the same way how the book has solved this question. Okay, and I tried to do it in some different ways, but I used the coordinate approach, but the calculations were really mind-boggling, so I didn't try to solve it in my own way, and I don't think any other solution will be as simple as this solution. Okay, the book has also has given this solution in the solutions section. Okay, all right, that's all for today. And I think I forgot to mention in my last video regarding the integrals, the reference for that video was the book The Use of Integral Transforms by Ian Naismith Snedden. It's a really old book. Okay, it was last published in 1973, I guess. Okay, that's all for today.